when we solve a multiple step inequality, we're going to solve it just like we would a multiple step equation, so all the same rules. So we'll undo the adding, undo the multiplying, undo whatever it is going on. We'll undo PEMDAS in reverse, just like you're solving an equation. The only thing is what since it's an inequality, do we need to keep our eye out for? The sign. So when is the sign ever going to flip? Just like yesterday, the only time the sign will flip is if we divide or multiply by a negative number. Other than that, it's just like solving an equation, just like we've been doing. You've been doing for years at this point. Okay, we'll skip this guy and we'll go right to the examples. All right, we'll solve this inequality. Well, what's the first thing we need to do to this thing to get x by itself?
Add 5.
So undo this minus 5. We add 5. So 2x is compared to 28. Does the sign flip or stay the same? 23 plus 5 is 28. Okay, so then what's the next thing we need to do?
Divide by 2.
X compared to 14. Is the sign flipped or stay the same? Stays the same because we divided by a positive number. Oh look, x is less than 14. Graph this. 14. Filled in, numbers less than 14. There's not supposed to be a huge space there, but my printer or my computer decided to put one in.
That's so funny.
Okay, so let's see. What should we do to this guy?
Subtract 5.
Because that's just nice laughing. I had to point it out to you.
Okay, we subtract it so the sign stays the same. Subtraction does not change the inequality. Okay, now what do we do?
Divide by -6.
Oh man, this other one just overwhelmed me.
Why? Ooh, 21 over 6. This is a fun one. Okay, how do we reduce 21 over 6? Fraction time.
Oh, I didn't reduce that. 7.2.
Okay, what goes into both 21 and 6? What number? 3. Okay, so divide each number by 3. What's 21 divided by 3? 6 divided by 3?
2.
Okay. And how does y compare to this new fraction, 7/2?
It is
greater than or
greater
equal
than or equal to.
Flip the sign. Okay. If you want to estimate where 7/2 is on the number line, what would be a good way to estimate where 7/2
Put
is?
it right.
Put it right in the middle.
Okay, yeah, so if we're doing a freehand number line, we'll put it there. I guess what I was saying is, what if I put the numbers in for you? What if I was mean to you? And just instead of giving you a freehand number line, I did this. Where does 7/2 go? 7/2. Where does 7/2 go? Between the 3 and the 4. In fact, exactly between the 3 and the 4. You can estimate 7/2 by dividing 7 by 2, and you get the decimal answer of 3.5. So 3.5 goes right here in the middle.
Just does, bro.
Okay. 7 over 2 is 3.5. So if I gave you the number line with the numbers already drawn in, you'd want to make sure you put that in the right spot, which is right exactly between the 3 and the 4.
Hey, Mr. Fisher?
Yes.
When we're like graphing it, can you just put the number and you have to make it a line?
Yeah, so if you're just making your own freehand number line, you can just do what we've been doing. That's fine. But keep in mind, I may give you a number line with the numbers already put in, and you have to fit your answer in there somewhere. Okay. Oh boy, how about if we throw a fraction in on, say, one side? How should we deal with this thing? Okay, one strategy might be distributing the negative 1/4. So you could do that. You could distribute the negative 1/4, and you get negative 1/4 p plus 3 is bigger than negative 2. How about a second strategy for dealing with this fraction? Okay.
Can you put multiply 1/4 by like both sides, but you put 2 over?
You don't want to multiply both sides by the same number. But excuse me, you don't want to multiply both sides by this same fraction. But you could multiply both sides by a special number. What would you rather multiply by?
Would it be 4?
You could multiply both sides by 4. There might be even just a ever so slightly better number to multiply both sides by. Maybe -4 to get rid of, since this is -1/4. You could multiply both sides by the reciprocal of this fraction, which is -4/1. If you multiply both sides by the reciprocal of this fraction, reciprocal and its original cancel out, and you get p minus 12. What's -2 times -4/1? 8. And how does p minus 12 compare to positive 8? Is it bigger than or less than 8? Less than. Multiply by negative, switch the sign. Add 12, p less than 20. Adding doesn't change inequality, so you have a 20 here. P is less than it. Okay, try to not panic at this point. But now, here's an example where we have variables on both sides. Okay? Take a deep breath before we proceed. I don't want you passing out from excitement. Okay. Now the word composure is reclaimed. If this was an equal sign, what would you want to do to solve this equation? Well, we'd like to combine like terms on any one side, but it looks like all the like terms are combined on the one side, on any given side. If we're going to solve this, you got to gather all the variables on one side. We said it's the first thing you'd like to do. Okay, so do we recall from way back when what side I suggested you gather the variables on? Francesca? The one with the more of the variables, or the larger coefficient, it's called. Okay, so given this, what side should we gather them on? Left side. So there's 9 x's here and only 6 x's here. Let's gather them on the left side. So what that means is let's eliminate the x's on the right side. Subtract 6 x's from both sides. 6x minus 6x is nothing. 9x minus 6x is 3x plus 6 compared to 21. And since I subtracted with a negative number, I'm going to flip the sign. Right?
Yeah.
Since I subtracted a negative number, I'm going to just flip this sign and we'll proceed on our way.
No. Yeah. No.
Now, when do I flip the sign again? I always get confused. When I multiply or divide by negative. Oh, I didn't multiply or divide, so I'll just keep it the same.
Wait, are you being serious?
Yeah, was that sarcasm?
Obviously.
What do you think, you guys? Okay, well, just because you graduated doesn't mean
He made it sound
better than
real.
us.
It's like hard to tell.
Subtract 6. 3x is less than 15. Divide by 3, x is less than or equal to 5. There's x. More importantly, here's 5. Less than or equal to, voila. Okay. Last thing for today, and on your sheets, I believe the 5 got cut off when it got printed on holy paper, so it cut off the 5. So make sure you get the 5 put in, so that our answers match up. It cut off that 5. Here's 3 questions, one of which is fine. The other 2, you're going to get some weird answers. Okay. What I'd like you to do is try to solve each of these. And don't necessarily worry about graphing all 3 of them. at the moment. But what I'd like you to do is at least solve them and get an expression at the end. It may or may not make sense to you right off the bat, but try to get an expression and see if we can check. Let's check our algebra if we're on the right track or not. Okay. We'll interpret the kind of the weird looking answers at the end. Okay. So get the expression and then we'll interpret what the expression means. So hopefully we're seeing that you should get 2x less than 8x less than or equal to 4. Or here we go. Okay, pretty standard answer. The second two, hopefully you're noticing, are kind of different. If we distribute out, you get 5m plus 25 is less than 5m plus 17. Then most of you said, well, okay, let's get the m's on one side, so I'll subtract 5m. That's nothing. Subtract 5m. 5m minus 5m is no m's. You say 0m or just 0. 0 plus anything is just itself, so we get this expression. 25 is less than 17. Is 25 less than 17?
No.
No. So then, are there any m's I could have chosen so this inequality is true?
No.
No. Therefore, there are no solutions to this. There was no solutions because this is not true. That is not a true inequality. There are no solutions.
That was on the other way. Say that the arrow was the other way.
How about let's do the last one. I think we'll get something like what you're saying. So, how do I graph no solutions? Any ideas?
There is no.
Yeah, they just can't put anything here. That means that there's nothing. I can't pick any point on here that gives me a solution. So this is just a blank number line. Versus our second example, well, we'll get something kind of similar. So if I distribute negative 4, you get 1 minus 8s is less than or equal to negative 4 times 2 is negative 8s. Negative 4 times negative 1 is positive 4. Let's get the s's all on one side. So if I say add 8s to both sides, negative 8s plus 8s is 0. Negative 8s plus 8s is also 0. And you're left with this expression. There's no s's. Is 1 less than or equal to 4?
Yes.
No.
Is 1 less than or equal to 4? Yeah, 1 is most certainly less than 4.
Yeah.
So what s's could I choose that makes this inequality true? Any s's. No matter what s I pick, I will always get a true inequality. Yes. Why do I know that? Because when I solved this, I lost all the s's. I lost all the variables. So the only thing really impacting this is the 1 and the positive 4. Is 1 bigger than or equal to 4? Yeah, indeed. So that means that this is always true. Or you could have picked any real number. Any real number works. Why? Because this inequality is true. Okay, so how do I graph any real number? Where does any real number fall on the number line?
Anywhere.
Anywhere. So how do I represent everywhere on the number line?
Arrow both ways.
How about I just draw an arrow that covers the entire number line? Would graph all real numbers. Okay. Nothing graph represents no real solutions. Choosing any real number means I can pick anything on the number line. So very similar idea to when we had equations with variables on both sides. We had to match up and see when the end is the expression true or not. If it's true, then good. Any number. If it's false, then nothing.